Hi, it's Daniel from TrustGraph, and we're now on to part 3 of my engineering thoughts. And this one is, what is data streaming? Well, where have we been before? I first talked about system reliability, I talked about network topologies, which I ended with pub-sub architectures, and now we're on to data streaming. Well, this is a term that we tend to use today for architectures like Kafka and Pulsar. And of course, TrustGraph is built on top of Pulsar. I'm going to talk about Pulsar a lot in this episode. But where does the term data streaming come from? It kind of has its origins in data science. As data science began to scale up and the amount of data they were working with, they tend to like to process their data in batches, which was getting written to disk, which is expensive, it's slow, and people that were familiar with real-time systems said, well, why are you storing this data to disk that you're not going to need a second from now? And that's kind of where this idea of data streaming came along. But when we really dive into how Pulsar works, you're probably, or may not, I'm actually curious how you, for everybody's comments on this one, you may or may not think the data streaming term is apt because what's actually going on underneath the hood at Pulsar is kind of something different. And I find fascinating. It's truly marvelous technology and incredibly complex. And I'm going to talk a little bit more about that as we go along. As I teased in the last video, I think the best metaphor for publish, subscribe at scale is actually thinking about it like social media and thinking about it like hashtags. Although social media doesn't tend to use hashtags as much anymore, but you create a hashtag and that allows you to find information just referencing that hashtag. And that's what publish, subscribe systems use. They create topics and then producers would produce data, messages for that topic, and then you would have consumers that subscribe to that topic. And it's all a very dynamic system. A producer can produce data that's attached to many different kinds of topics, and a consumer can choose many different types of topics to consume. And they can choose to unsubscribe to a topic or to subscribe to a topic, just like you do with social media. Every time you open a social media app, you can subscribe to new providers, you can unsubscribe to them, topics as well. Very dynamic. And I think everybody would agree that the technology and the data infrastructure underpinning social media is incredibly complex. And it's no different in technologies like Pulsar. And I said in the last video too, these architectures are a bit like a star, bus, and a mesh all in a single architecture. And what did I mean by that? Well, if you're just publishing and subscribing to topics, that seems an awful lot like, a central hub. I send data to this thing and it sends data back to me. And I don't really know what's going on underneath it. And if you're just a publisher and a subscriber on one of these architectures, that's all it kind of looks like to you. But you start getting underneath the hood and it kind of operates a little bit like a bus, how you have this rail, that you have this backbone that the data flows on, and you can just kind of grab onto it at any given point, and you can quickly scale up. New publishers and new subscribers can just be added to the system, kind of like a bus. But then how is it like a mesh? Well, anybody that connects to this central data fabric can connect to each other. But you don't need wires. You don't need persistent wires. You just need to be able to publish to a topic and subscribe to a topic. So logically, it kind of works like all of these, even though physically it doesn't really have any of those hardwired connections. And that's why it can be really tricky to visualize. I'm not going to really have any visualizations in this talk because, well, it's really complicated. I've I've looked around. I've used AI to generate quite a few, and they all get really complicated really quickly. And I think that's why it can be really intimidating when you start looking into technologies like Kafka or Pulsar and trying to understand, what's going on here. And I hope this talk gives you a little bit more insight into how they work, and why they're necessary. At least the three most common types of pub sub architectures out there right now that you might hear about are DDS, MQTT, and of course Kafka and Pulsar. And again, Pulsar is the backbone of TrustGraph. They have different use cases. DDS is often used in real-time applications. So and back in my aerospace days, on like an aircraft network, how the actual avionics backbone was structured, would often use DDS. It's actually used in autonomous vehicles as well. MQTT, you often hear about in IoT devices where really lightweight deployments are necessary. And cloud native, well, that's really where Pulsar comes in. It was designed to be cloud native from the very beginning, so to deal with huge volumes and velocities of data. I can make a lot of videos for the next 2 months on all of the components of Pulsar, and I just decided to pick a couple of the big ones that I think are really important to understand. And the first one that's obvious is topics. You create a topic, you publish your topic, you subscribe to a topic, and that's how the queues get generated. Then you have brokers that are exchanging this information. And of course, you need the metadata associated with all the messaging queues, the topics, the configuration of the producers and the consumers, and then the bookkeeper. The bookkeeper. So the bookkeeper is really recording all this happening. And then there's ledgers inside of all of this as well. And you might be thinking at this point, bookkeepers, metadata, ledgers. Well, sounds like you're storing data. Well, let's dive into that thought. One of the concepts is really integral to Pulsar is write ahead logging. What does that mean? What that means is that you create a log of what's supposed to happen before it happens. So if Alice is supposed to send a message to Bob, we actually record that in the log before the message gets sent. Now, why would we do that? That seems unnecessary. Well, what happens if the message isn't received? We want a record that the message was supposed to be sent, and now we can go, well, the message didn't arrive. Where is it? Well, let's resend it. Now, for small scale systems, this isn't really necessary. But again, think about how this had its origins in data science, where you might be processing 10,000 documents. Well, what happens if 10 documents in the middle just didn't get processed? How would you ever know? No one would be able to, nobody's going to go through manually and go through like document 5,555, document 5,556, and go through and that they were all manually processed correctly. That's the whole point of creating the automation, that you don't have to do that. So you would have this system that can make these records so that you know that everything was processed and everything was correctly sent. Now, as you can imagine, there's some ideas that I don't hear talked about as much as they used to be, and that's in the idea of best effort versus performance guarantees. I used to hear this a lot in the kind of deterministic world, that you have best effort, and that's when you're just sending something across the network, especially if you think in the UDP sense, that we sent it. If it's received, great. If it's not, well, we did our best. Well, what happens when that's not good enough? When you have to know that the message was received, and you have to know when the message was received. And if it wasn't received, that you need to resend it. Well, that's when a system like Pulsar comes in. It also comes in for the performance guarantees of gigabit per second plus throughput and millions of messages per second. You may have heard me talk about what is scale. Scale is when you have the volume and velocity of data requiring these sorts of systems. And this is something we're going to get to in the next episode. We're talking about storing data, aren't we? A little bit. Data that you might need and maybe you might not. Data that you might want to store permanently. Data that maybe you need to be able to recall and then throw away. Let's dive into that topic next time.